Howdy, folks. How's it going? How's everyone doing out there at Global Hack Week Land? I know y'all just had opening ceremony with Mary and Siddharth, so I hope y'all are super excited. Let us know how excited you are in the chat. Would love to hear from you. My name is Rosendo from MLH, and I am here to introduce a really awesome workshop that's going to be happening in the next couple of moments. So if you're familiar with Auth0, you'll know that they are an authorization and authentication platform. We've been using them for quite some time now at Global Hack Week, a ton of great challenges that are going to be available to you. But for right now, we have a really awesome workshop that's going to be AIML related. We're going to have someone from the Okta team, also, part of Auth0, come in and teach us how to build a RAG application that is secure, because that is really like what the main purpose of using Auth0 is. So making sure that your applications are secure, and any type of application will do. So without any further ado, I'm going to go ahead and bring Juan Cruz Martinez up to the stage here. Please give him a warm welcome, y'all. Welcome, Juan.
Thanks, Rosendo. How's it going?
Yeah,
Hi,
it's
everybody.
going well. All right, I will leave you to it, and yeah, let you get a quick introduction out to the crowd, and let me know whenever you want to get started.
Yeah, absolutely. So let's get started with building a secure RAG application. And today we are going to be focusing with Python. We're also going to be using a framework called LangChain, and we're going to be using something called OktaFGA. And if you don't know what any of these things are, don't worry. We're going to be covering all of them in detail. Let me jump into my screen, and so you can follow along with me. We're gonna start from the start, really taking really covering the basics of what LLMs are very quickly, going through what is the reasoning behind RAGs, why do they what they are and why do they exist, and then we're gonna do a live coding session where we're gonna build a secure RAG application, which is gonna be the fun part, right? So make sure that you stay tuned for that part. But let's get started, right? So how do LLMs in general work, right? So normally we have someone like us here on the one side of the spectrum, um, that sends a question to an LLM system that could be like ChatGPT, it could be Llama, it could be Claude, it could be like any DeepSeek. Now that we have DeepSeek, right? It could be any of this, and the question could be something like, for example, which days are holidays this year, and then the LLM will feed a response. Like, for example, it may say, here is a list of federal holidays in, right? And different systems will reply to this differently. The reason why is different systems will be trained on different data with different parameters, and they will have different configurations. For example, if we prompt this question to Grok from X, I know it's not the best example, but it's there. It's one of the important ones. If you ask this question to Grok, well, Grok doesn't even know where are you based, where are you located. So it will reply a generic response saying like the holiday lists in the US are regardless of where you are from, right? So I asked this question just before this workshop, and I got answers for 2024, so not even for the current year. And I got answers for the US, even though I'm located in Germany. So that was not good. ChatGPT was a little bit smarter. It tried to figure out my location based on my IP, I guess. I'm not really sure, but after reasoning a little bit, it gave me an accurate response of holidays in Germany, which is where I'm from. And that is great, right? So there are things that LLMs can do to try to be a little bit smarter, to provide better and more detailed information to us, but they always depend on the same source of information, the source of information they used when they were trained, right? So that's what they know. That's all they know. They cannot take up new information. And what happens when we want to have private information handled to these systems, right? Like, for example, let's say my company doesn't follow all the different holidays that are the public holidays. Maybe my company gives me also additional holidays. Maybe my company says uh, f- uh, the time or the week between Christmas and New Year's is also time off. So how will an LLM, let's say I have a chatbot in my company that my employees can interact to, how can my employees question that chatbot, and that chatbot will reply based on the policies that are set by my company, right? Because that information is private and it's not information the chatbot was trained on. So yeah, so this is kind of like the question Batman here is posing. What if I want to know the holidays that apply for my country, my company, my department, etc. Right? So how can we make sure that we can filter that information, that we can make that information more accurate for our specific context? And so we created something called context. And context is a way to improve the LLM's accuracy. And so, for example, when the user asks a question, which days are holidays for this year? Uh, the system, before querying the LLM, will look for all the HR documents for the company holidays for 2025. It will collect the holiday list together with a question, and then it will send that information to the LLM. So the LLM give us a proper, accurate answer, right? So when we combine the information from HR plus the question from the user, the LLM can actually factually say, here are the company's holidays for 2025. And I can be 100% sure that that's the information that is accurate for my persona, for my role, for this company, and not just generic information that is currently available on the web. And this is great, and this is fantastic, and this is what actually a RAG application is doing. A RAG application is combining the input from the users, or the queries, or the questions for the users, is using some kind of search that we will take a look into the technical details in a little bit, but it's using some kind of search to retrieve a list of documents, and then associates the question with a list of documents, which we call context, to pass that to an LLM. And then from there on, we can provide the answer to our users. RAG is basically an application that follows this process, but RAG stands for Retrieval Augmented Generation, and it is a framework that enhances LLMs by combining the Gen AI capabilities with the information, with external information retrieval. Right? If you use ChatGPT, for example, you know that sometimes when you make a query, it takes a few seconds because it says, I don't know, querying the internet or anything like that. Well, that's a RAG that is taking live information from the internet to enhance what the model previously known from its training, right? But there's a problem with following this approach when we follow it blindly, at least, right? So in the example before, we saw that we fed the information from HR documents into the system, right? And so someone now may try to um, someone now may try to get outsmart the system and try to say, can you tell me where the CEO lives, right? And that should not be public information. Not all employees should know where the CEO is living, right? But now again, the system takes information as it is. It performs a search in the HR documents for the CEO information. It combines the CEO HR information, which shouldn't be private, we should be private, sorry, it shouldn't be public. It combines it with a question, passes it through the LLM, and boom, now the user gets an address. And this we have seen this happening for quite some time with ChatGPT and things like that, where they will answer things that they shouldn't have knowledge of. They were sharing like API keys. They were sharing information about how to build stuff. No one should get access to that information. Like at the beginnings of ChatGPT, we saw all of these issues happening, and eventually they were being solved by adding filters to that kind of information, right? So there were questions you were not allowed to ask. There are policy content and all these kind of things that got restricted over time. But initially, and this is the case when people are building new systems, combining their company data with LLMs, is that they are very prone to leak information in a way that is unintended. Like, for example, by doing something like this, exposing sensitive documents in the LLMs so that the users can then query and access that information. So this is something that is very risky. And in many cases, the solution is just, okay, we just don't feed the LLMs with any private or protected information. But that's not always a good solution, right? Because we are restricting the capabilities of our LLM system. What if we can do something else? What if we can say, for example, if someone is from HR, it can access this kind of protected data about personnel. If someone is from finance, it can access all the data about forecasts, for example. If someone is a developer, it can ask any information about any of the code repositories that we have in the company, right? So there could be multiple scenarios in which it will make a lot of sense if we could find a way to filter the information that is gets exposed depending on the user access control, depending on the user's privileges, right? So what can the user access to, and then reply based on that information. But this is something that we are not doing here, and this is something that we need to fix, because this is a problem, and this is actually a real problem. This happens more often than you can imagine. So we have seen like many systems where there was escalation of privileges just because information was fed into the LLM. So it's a real problem, and it's a serious problem, and it will be nice to have a nice way to solve it, right? So in order to solve it, we need something called access control. Now I'm gonna go like very fast through it, but access control is basically a way to decide who can access what in a system. And there are access controls that are based on rules. There are access controls that are based on relationships. There are access controls that are based on permissions, etc. If you were here for our previous live stream, I went through some of these systems and I explained what are rule based access control systems, what are permission based access control systems, and others. I think that's also gonna be live on YouTube, or on the website, so you can take a look into that one if you want to know more about access control. But today we are going to implement a very particular and interesting access control system called relationship based access control system, which is a very granular and fine way to give access to users to resources. And I'm going to explain a little bit more through as we build the demo, as we go through the screens. Um, but yeah, so keep that in mind. Whatever is your access control layer, whether you're using something like roles and permissions, or you're using relationships, or if you're just using a library with a bunch of if statements, no matter what it is that you use to decide who get access to what, we need to put this access control system in the middle of the document retrieval, so where we query the documents in a database, and the LLM, right? And this is how that looks like. So now when someone asks, for example, can you tell me where the CEO lives? We search for the HR documents for the CEO information. Then we filter the documents based on the user access. In this case, we don't have access to these documents. So when we get the response will say, I'm sorry, I don't have answer to that question. However, if someone from HR logs into the chatbot and performs the same question, they will get the proper response. And this is what we want to build today. We want to build a RAG system that will allow us to uh, have some type of questions that the user will be entering, let's say a chatbot, for example. And then we're going to retrieve information from a database. We're going to be filtering those depending on the user access. And then we're going to be outputting that information after we call an LLM. In our case, we're going to use ChatGPT, or OpenAI platform, but you can use any other system that you wish. So, how exactly a RAG system works when we go into the technical details? Because so far we have been covering just like this contextual idea, but everything starts with a vector database. And the vector database is where we are going to be storing all these documents, all this information that we want to use to query, right? So this is where all the information about the company, about your product, or whatever is it that you want to query is going to live in this vector database. And the system really lives in two phases. The first phase is to load information in the database, and the second phase is to query information about the database. So on the first phase, we basically load the documents. Loading the documents could mean different things depending on your context. Your documents could be living in a folder, they could be living on a website, they could be living on a database. So how you load the documents will be very specific to how your information lives in your company or in your organization. Then we generate chunks. What are chunks? Chunks are documents that have been splitted in smaller pieces, because you can imagine some of the documents perhaps we are uploading are PDF documents with thousands of pages, and LLMs are not very good at dealing with such a huge amount of information. Context windows will start to have issues there. So what we do is we split the documents into pieces of text called document chunks, and we associate all those chunks to the original document. Once we have all these chunks, then we vectorize the chunks into something called embeddings, and we store the embeddings in the vector database. All this we do thanks to the function of libraries. We don't really need to worry. Nowadays, we don't need to worry about creating our own embeddings or anything like that. If you use OpenAI, OpenAI provides functions and classes to create your own embeddings. If you use any RAG framework like LangChain, Llama Index, or any other, will also provide methods to generate embeddings, and even different vector databases, because there are multiple available in the market. There are in-memory vector databases. There are others that are hosted solutions, etc. So all of them will provide ways for you to create the embeddings that you can use to store in the vector database. Once everything is stored in the vector database, is ready to be used by the RAG system. So when a question comes in now, we don't process the LLM directly, but the first thing we do is we vectorize the question.
Hi, Juan. Sorry to interrupt here. I was folks in the chat are just wondering if you could zoom in on the text here a little bit because it's a little hard for them to
Oh,
read.
yeah, sorry.
Yeah, no worries.
Let me see if I can do that. There we go. We're also gonna share the slides, and I think we can also Rosendo, share the slides after this.
Yeah, absolutely.
Yeah. So we're gonna also share the slides after this, so you can take a better look into it. But yeah, I now zoom in, and I'm gonna be moving as we move through the explanations. So, so when a question now comes in, the first thing we need to do is to vectorize the question. That means to convert the question into embeddings itself, and then we can use those embeddings to query the index database. The vector database will then return the document chunks that we can use to filter depending on the user access, and then from there query the LLM and get the result, right? And this is basically what we need to implement. We need to a RAG system will consist in these two phases. We need to implement the loading of documents. So this is going to be the first important part that we need to do in our implementation. And the second part is giving a question or a prompt by the user, querying the database, retrieving the documents, filtering, and getting the LLM information in here. All right, so I'm gonna zoom out a little bit now as we move to the next slide. Keep this in mind for a little bit. We're gonna come back to it when we do the implementation. So don't worry so much, but yeah, keep in mind more or less the overall flow of information, how it's happening here. And now let's talk a little bit about what we can use as an access control system, right? Remember when we were discussing about access control, I mentioned there are multiple ways that you can go about access control systems, and there is an open source solution called OpenFGA. I'm gonna open that here, openfga.dev. We're also gonna put it here on the screen. But it's openfga.dev. This is an open source access control system based on a relationship based access system. This will allow us to have very granular and fine control. It is an open source project. Now, Auth0 offers a hosted instance that you can use for free with some limitations, but there is a free version of this, so you don't need to run it yourself. And this is what we're actually going to use today. We're going to use the free version offered by Auth0 at fga.dev. So we're going to also share that link here on the screen, fga.dev. This is what we are going to be using today. Um, and this is the access control system that we're going to use. And the reason why is because it's very granular and it allows you to simulate most scenarios, and it allows you to really go into uh, any type of scenario that you need to build. To give you an idea, this system, OpenFGA, is based on the same system that Google uses for its internal systems, and for example, for things like Google Drive, Gmail, and all this stuff where you can share to the organization, you can share to individuals, you can share to groups, and they use something that is based on the same principles as OpenFGA. Right? In fact, OpenFGA was built based on a paper from Google. So it has been very well proven to work, which is great for us. So OpenFGA is a decision engine that makes decisions based on an authorization model in combination with tuples, saving a database. It is a mouthful. I know we're gonna get into the details when we go through the screens and the explanations, and we actually build the thing. It will all make sense when we are building it. Don't worry. All right, so it's code time, right? Um, so the first thing we're gonna do is we're gonna get a little bit familiar with the access control system, uh, OktaFGA or OpenFGA, because um, that will be easier then to understand everything that is going on in the code. So I just logged in with my account. As you can see, I'm with a free trial. The free trial is not time bounded, but there are some restrictions on the number of calls you can make per minute. Of course, for any demos that you need to generate or anything like that, this is more than enough. Um, but yeah, so when you open for the first time your OktaFGA dashboard, when you after you sign up for a free account, you will be offered to create a new model. A model is a representation of uh, objects or resources and users. And you can really define anything that you like through a model. So you can define things that are types. So, for example, a type can be a user, a type can be a document, a type can be a folder, a type can be a person, a type can be an organization, a type can be a group, a type can really be anything that you want to use to classify different objects. And then you can build relationships between types. So, for example, let me zoom in here a little bit more so we make sure everybody can read. I don't think I can make it bigger than this, otherwise it will not fit on the screen. But in here we define a type user. So we know users are going to be playing a role here. And we define a type document. And then we say there are relations. And we can define a relationship, which is an owner. So an owner of a document can be a user or a viewer. And we can say that a viewer of a document can be a user or the wildcard of a user. And this will basically mean any user. Um, we can also define more interesting relationships. Like, for example, we can say we have a type folder, and then we can say that the relations, and then we can say define, and we can say parent. And what is the parent of a folder? Well, it's simply another folder, right? And now I can also say to the document, right? I can define a new relation here and say define, and then I can say folder, and this is of type folder. And like this, I just build Google Docs authorization model, right? Where you have users, you have folders. Those folders will have parents. So you have a parent folder, and you have and then you can build a whole hierarchy, right, of folders. And then documents belong to a folder. So this is basically the model of Google Docs. But yeah, let's simplify it for now. Let's just keep our users, and our users will be directly related to a document through either the owner property or the viewer property. So once you have your model in place, we can go here into developer mode tab here on the left side. And we can see here that we have also Um, Again, we have the model, and we have two more columns. We have tuples, and we have assertions. Um, yeah, so tuples are relationships between objects. Like, for example, I can add a tuple and I can say the user Peter is related to a document, and the document could be, for example, the document 1.pdf, and the relationship is owner, right? So here I'm saying that Peter is an owner of 1.pdf, right? And then I can save that, and that gets added to the database, and from there on we can query when we ask at some point in the application, does Peter has access to the document 1.pdf? Then he will say yes, or he will say no. Um, so that's how we will go about it. I already have two tuples here created. One is using the user wildcard, so the star here, to say that everybody has access to public documents, but only admins have access to the private document. And this is going to be important when we build the application, because we are going to divide documents into two categories, and depending on your user access, you will be able to get replies based on the public information or the private information from the company. But yeah, so this is basically what we need to know for now for OktaFGA. Now let's jump a little bit into the code side. Meanwhile, I'm going to check if we have any questions. Okay, so we have a question here. If the questions are too big, should it also be broken in chunks? And so the answer is no. And the reason why it's so, if the question is just too long, it will just not fit in the context window. So you have to do some other treatment in there. If you break it in chunks, you will have to basically run your rack pipeline uh, n times, depending on how many chunks you have, and it will not make sense. Um, Nowadays, this is very rare for happening, at least for questions, because if you think about models we have like a 128,000 context window, so the question will have to be extremely large um, for it to not fit. So like the short answer is no, you wouldn't have to break it in chunks. We have some other questions. How are we generating the graph on the right side? I guess this is the graph that is related to the model. So the graph is generated automatically, and this is just showcasing the relationships that you have described here in the model. As you type in new relationships, it will automatically sync and show the new graph. It's pretty neat. It is a built-in feature in OktaFGA. I think it's not part of OpenFGA, because OpenFGA only runs like in the background, kind of like a process, and there is no like a dashboard UI to handle it. You can work everything with APIs, but the dashboard is part of like OktaFGA. All right. So now that we answered some of the questions, let's get back to or let's jump into some code. All right. So I already did some pre-work, and the reason why is this is only like 1 hour, and building everything will take a little bit more time. Um, but let me show you what I have so far. Hopefully, everybody can see well the screen. That we have a good text size for everybody to see. So the work that I pre-did is I created two helpers. One of them is called the memory store, and the other one is called read documents. Read documents, very easy function that takes a directory name that we have here called docs, and it loads two different files. One file is called public doc.markdown, and the second file is called private doc.markdown. And the only thing it's doing is open them with Python as read mode. It reads the content, and once it reads the content, it creates a list of all the documents, and it uses this document object to specify the content. And the document object is part of LangChain, which is the framework that we are going to use today. So very simple code. It simply adds the content here. This is a scenario that is you will never or almost never find in production, because normally you'll read documents from different sources like the web and databases, and probably not by linking them by hand one by one. But this was the most clear way to explain it here today. So we have the read documents folder, and we have the memory store. The memory store is simply a index database, and what is this doing is importing files or face. I never know how to pronounce this in English. My Spanish background always read it as files, but it could also be face or something like that. Um, but face is basically an in-memory vector database. So the vector database that we saw on the chart on the right side, that's what this is. And then we are using OpenAI embeddings in order to transform the documents into the chunks and then store them in the database. So we have a question here on chat. How do we integrate a RAG pipeline into a web application? Probably one written in TypeScript. There are multiple ways that you can go about it. You can write your own pipeline in TypeScript. So the same things we are using today, FICE, the vector database, is also a library for TypeScript. It can also be an external database. LangChain has support for TypeScript and for Python, so there's no problem there. Pretty much the same code you have here today, you can apply in a similar fashion on TypeScript. Other programming languages depends, but Python and TypeScript or JavaScript are very popular in the AI space and in the RAG space. So there are the libraries. If the library is working for Python, it will very likely work also for JavaScript. All right, and we have another question. So, what is a vector database? So, a vector database is a database that specializes in storing text information that can be queried through embeddings. So normally when you have a regular database, let's say an SQL database, right? You need to write your queries like select, and then you need to be very precise in the way you query the information. You can use things like wildcards through the like filter and things like that, through the like word condition and things like that. But you have to be very precise with the way you retrieve the information. Vector databases basically allow you to do full text index search on large amount of information. Right, we have another question. What is LangChain? So LangChain is a framework. It is an open source library that allows you langchain dot langchain.com langchain.com. There we go. They have library for Python and JavaScript, but it's basically a library that allows you to build RAG applications. That's pretty much it. We're gonna put the chat here as well. So you have also the link to here, but langchain.com. This is one of the most popular frameworks. There's another framework that is very popular called Llama Index. Again, same idea. They're actually quite similar in nature. But yeah, so you have a few options when you want to build a RAG application. LangChain and Llama Index being the two most popular options for Python and JavaScript. All right, so going back to our code now. Basically, when the memory store is basically what loads the database into memory. So it creates the OpenAI embeddings, and then it creates the vector database and adds the documents to the database. So this is everything that it's doing. We don't need to worry about, like I said before, right? We don't really need to worry about how do we create embeddings or anything like that. We just define the parameters when we create the files database. We just telling them, okay, this is the embedding model that we want to use. In this case, we are using this one from OpenAI, and we pass it like an index. This is just like some default values. The doc store, which is an in-memory document store. This is just for our case because we are really using a a demo. But if you want to go into something more production grade, you'll probably replace files with a proper vector database. There are multiple out there. I think Amazon has their own, Azure has their own. There are also open source options. There's also files can be run as an independent database, not just as in store. Um, so yeah, so there are multiple options to do that. But that's basically what we do. We just initiate files, and then we have our memory, what we call our memory store in here. All right, so let's go now into our main.py, and here's where we are gonna start doing things. We are doing some loading some environment variables. For now, we have OpenAI key in our environment variables. So here's our key, and then we have some OktaFGA information that I'm gonna show you in a minute how to retrieve. But yeah, let's start doing some coding. So the first thing that we want to do, like we said, is we want to load the documents, right? So we want to do documents, and then we're gonna get the list of documents by calling the function read documents from our helpers. And like that, we loaded our two documents into that array, into that documents variable. Then we need an instance also of the vector database. So we're gonna call our vector store, and we are gonna do memory store dot from documents, and then we pass in the documents here. Documents. There we go. Let me check if there are any questions. All right, I think we're good. So we have our documents. We have our vector store with the documents already loaded. And another thing we're going to need is a prompt, right? Like a system prompt for the LLM. Something like you are an assistant that answers questions based on context only. All right. So this is going to be our prompt. You're an assistant that answers questions based on context only. That's good to now to start, but there are things that are going to change a little bit here. We'll see that in a minute. Let's call this not prompt, but our prompt text. And then we are going to do prompt equal. And because we're using LangChain, there is a way to build prompts from text. And we're going to use one of those methods now. So this is called chat prompt template, and it's not highlighted. Let me import it by hand because I'm not really sure what is happening with my editor today. But it's not liking that I'm the auto imports. So from LangChain prompts import chat prompt template. There we go. And now chat prompt template dot from template. And in here we basically pass the prompt text. Okay. So far the only thing we did is load our prompt text into a way the framework requires. That's it. That's the only thing we do. And now we need the LLM instance. And if you use OpenAI libraries before, you'll see that this is much simpler because the only thing we need to do here is we need to do chat OpenAI. There we go. Thank you for auto completion. Oops. There we go. Chat OpenAI, and then we pass the model, and we say GPT 4.0 mini. Now there's a new one, I think, right? I think we have now, uh, what is it now? O3 mini or something. Let's stick to this one. All right. So we have our vector store already defined. We have our prompt, and we have our LLM. So we are quite good. The only thing we need to start doing now is we need to create a chain, and the chain um, is basically the RAG pipeline. So the way the RAG application is gonna be working. And the first thing we need to pass is something called context. Or the first thing we need to pass actually is is an object, and this is basically all the properties um, that the RAG pipeline will be using throughout this execution. So we know there's gonna be some context, and for now I'm gonna hard code the context um, with something like, I don't know, I like the color red. Yeah, for example. So now we have a hard coded context, and then we have the question is another variable uh, that exists for the chain. So the question, and for the question, because it's a special variable that is coming from the user's input, we want to make sure that we just pass it through uh, without any work to it. So we're gonna use something called runnable pass through. There we go. So this is how we define, um, yeah, our context. Let's say so that's the object, and then we're gonna pipe. We're gonna pipe, and to the pipe we're gonna pass the prompt, and then we're gonna pass the LLM. So that I save now, it should be easier to see. So the chain will basically be this is the information that the chain has coming from the exterior, like the context and the question from the user. Then there's a prompt, and then there's an LLM that we're gonna pass, and then we need to print the output because we just want to print the output on screen, and we don't want to do anything with it. We're just gonna be an we're just gonna use a string output parser. This basically gets rid of, when you call the OpenAI API, it doesn't just return the text, but it returns the amount of tokens you use, etc. Well, this just strips off everything and just keeps the response for us to use, which is the only thing that we need for now. Let me check if there are any questions in chat. Is there any way for the user to override the system message prompt? Um, no, the way we are passing it, because the system prompt is now here kind of like hard coded. But you can have, if you take a look to ChatGPT, what it's doing, right? They give you the option to override it, and basically you will have a database call or whatever that is stored, and then you will pass the prompt text based on what the user selected. But the user should not be able to override the prompt if the prompt is well prompted. If your prompt is too generic, too basic, if you just says you're an assistant that asks questions, then the user may be able to play with it a little bit around. So you will have to still be a little bit careful about the way you build the prompt. And normally saying something like just focus on context or context only is enough for it to stop replying to questions like how far is the moon or things like that. Um, so if you keep it context only, you are much safer than if you just keep it generic. And then we have another question: how to use access control in our RAG application. Uh, so so this script, right, will have a given question, a given input, and then it will give you a response. And then you can put this in either in an API, or you can put this in an AI agent, or you can put this running in the background in a background process. So it will be up to you what you do with the information. So we will see now is that the next step for us is to actually call the chain, right? So what we're gonna do is we're gonna do chain.invoke, and this will basically call the chain, and in here we're gonna pass the question, like for example, what is my favorite color, right? Now, based on the context, my favorite color should be red. So let's see what happens It's not really gonna work, but let's see what happens because I'm a little bit curious. So I'm gonna run that with Python main.py, and now when I try to run it, um, yeah, so it is complaining, it is breaking, which I expected to not really work very well. And the reason why is um, we have some issues with the context, because the context cannot just be the context cannot just be this string. So the context should actually be something in the way of a vector store of some kind. So we're gonna get rid of that, and now we're gonna say vector store, and then we are gonna say as retriever, um, which is the way the context is expected to be. And now if we rerun this, all right, it worked, but we didn't see anything. And the reason why we didn't see anything is I forgot to print the result. My bad. My bad. I forgot. I totally forgot about the result. There we go. We run it again. All right. And now it says, got it. Please provide the context or ask your question. So it doesn't seem that it has a context, and it doesn't seem that it has a question, even though we are passing it here. And you may be wondering why. And the reason why is actually our prompt text. Our prompt text needs to contain information about that. It needs to know about what the context is. So what we're gonna do is we're gonna say, let's say we press some enters here, and then we say context equals, right? So we tell the LLM that your context is actually going to be context, and we use the brackets to relate to the information that is here in the chain. So now it knows what the context is, but it also needs to know what the question is. So the same thing, question, and then we pass our question. So if we will have more variables or more things that we want to add to the LLM or to the pipeline, we can also reference them here in the prompt. So now that we added that and we query again, of course, my question doesn't make any sense. So it says now the context provided does not include any information about your favorite color. And that's true because if we take a look to the documents, there's a public document that talks about a company called Seco. It's basically an introduction to the company or a company overview. And our private document contains information about the forecast of Seco. So nothing related to our question. And so let's just change quickly the question. What is Seco forecast? And we run again. And we get information about the forecast. Now, this is great, except for the fact that that information is really private, and I'm not even in the context of a user here, and I could retrieve that information. So what we're gonna do now is we are gonna be using a library from Auth0. So Auth0 has this fantastic website called Auth0 .2 AI event. I'm gonna be posting the link now here also on chat. There we go, which is authentication and authorization for generative AI applications. And in here, you can take a look into a lot of details on how to do authorization for RAGs and all these things. But we're going to be using a library from them. And the library will basically allow us to change this vector store that we have here for something that will automatically check FGA, right? Which is this instance we created before. And so FGA will now allow me to say, okay, so there is a base retriever, which is our vector store, So this is as we had it before, same thing. But then we also have this build query. And this build query is a Lambda function that given a document, and the document is of type client batch check item. But basically, yeah, given a document, we are gonna return the user, right? So similar to like when we were in OpenFGA, who is the user that is authenticating? Let's say it's Juan, and then what kind of object do we want to access? So the object now is doc, and then we're gonna have to access the doc metadata, and then from the metadata of the document, the ID. I'm gonna go back to chat in a minute as we get this done through. I need to speed up a little bit because of time. And the relationship is viewer, right? And now I need to close that. Yeah, there we go. So now we use FGA retriever, and FGA retriever it's a class part of Auth0 library. If you want to take a peek into the class and how it works, you also find all the sample code in the URL we're gonna be putting now on screen and on chat. So that you can get access to this library. This is something that we are still working on. So it is provided with a sample code that is right there, but we are working on having a public version of the library in the next few days. But for now, you can access this class. But this class will basically have you provide a retriever, which is how you normally get the documents, and then you say how do you query who has access to what, and so who is the user, what is the document, and what type of relationship you have. Now, the documents metadata will heavily depend on how you loaded the documents. In our case, we decided that the ID is the way we're gonna go checking if a user has access or not to it. So you can define multiple different things, right? You can have as part of your metadata the classification level, if it's private, if it's secure, if it's confidential, so that kind of stuff. And now if I run this again, so Juan shouldn't have access to financial information. And there we go. The provided context does not contain information about regarding SICO's forecast. But if I change the question and I say, what is SICO, right? Which is part of the public document, now I should get the answer. And there we go. Now we see what SICO is, right? But now, if I go back to the forecast question and I change the user to admin, admin should be able to have access to the forecast. So when we run again, boom, we see that admin has access to the forecast, right? Let me go back here. All right, so let's go back here to the code. Again, right? So the chain is very simple. You provide like a set of parameters for the chain. One of these parameters is the context, which we use this Auth0 FGA retriever, and the question, and then you pass your prompt. Our prompt is very basic here. I'm pretty sure you all can do much better than what I did here, but feel free to play around. Take a look to the example that we posted there on the screen and on chat. That is it's pretty much the same example we built today. It's a little bit different because it uses a class to have this a little bit more clean, but it basically follows the same steps, the same patterns. It has the class. Feel free to experiment with that. Go into OktaFGA, sign up for a free account, create your model. In the example we gave you the link to, the README file also contains information on how to run everything, how to create your store and get all your secret keys and secret values. I wanted to cover that today, but I think I didn't have enough time, as I will prefer to maybe get some time for some final questions. Okay, so we have a question. How do you come up with the 1536 dimension? How does it? Yeah. So that is actually a very complicated question, maybe to answer right now here in this section. But I took it from the FICE documentation. It is kind of like one of the recommended values. It has a lot of dependencies on the way like you do the chunks and you do the embeddings and you do a lot of things. But if you go into the FICE project, which also belongs to Facebook, they have pretty good documentation, and they go over that also with quite some research explanation. Um, yeah, so I recommend that you take a look into FICE or face.ai. Let's put that also here on the let's put that also that here on the screen. I don't know if you have any other questions. If not, well, it's been an absolute pleasure. Hopefully, everybody could learn something new today.
All right, hackers, any final questions for Juan before we send you out into the wild world to build your own secure RAG application? I see one final one about the slides. Yeah, we'll make sure that we post the slides. Those will likely be in the Global Hack Week Discord. So just keep an eye out there for those after this, and that way you can walk through and see all of the content yourself. But otherwise, let's give Juan a big thank you. If you want to go experiment and build your own RAG application, certainly follow along with the slides and other content he mentioned. We also have some other challenges as part of the Global Hack Week week, so you could go and check those out to learn more about Auth0 and get started. And if you want to learn about more from Oracle, stay on, and we have another stream coming your way. Thanks everyone for tuning in, and thanks again, Juan.
Thank you. Thanks for having me.